All right, so for number one, it asks you, well, it said to verify that it was an isosceles triangle. So it's already telling you it's isosceles. It wants you to show it, right, or verify, and that means find the lengths of the sides and show that two are the same. The benefit of plotting it is you can kind of narrow down, right? I don't have to try all three sides. There was two sides that looked like they were closer in length, so I used those and found that both of them were the square root of 29, so showing that they're equal is enough to prove that this is isosceles. Remember on the quiz, it's not going to say show that it is this. It's going to say classify. So you're going to get 3 points. You're going to have to figure, it's going to ask you for the length of all three sides. You're going to find the length of all three sides. And then you'll classify it whether it's right, isosceles, equilateral, or none. Okay? Questions on that one? And if I'm giving the answer and it's a square root that can be simplified, like square root 32, something like that, I'd have to break it down and show that that would be 4 root 2, something like that. Yeah. Then you can do both, but you would have to check a squared plus b squared equals c squared to show that. Yeah, so if it's like a 45, 90, it's isosceles and it's right. So it could be both. Okay, question 2 said find the center and the radius of the circle with the endpoints of negative 1, 2, 3, 4, and then find the equation of the circle. So the center, I used the midpoint formula. I got 1, 3. The radius would actually be the square root of 5. I took the center and I took the coordinate point that was 3, 4 and plugged it into the standard form. And then from there, I got the equation, which is x minus 1 squared plus y minus 3 squared equals 5. Raise your hand if you got both right. Great. Okay. If you didn't, if it was like a silly mistake, that's not, don't be scared. Okay. People make mistakes all the time. If you had no idea how to do either of those, then you've got some work to do over the weekend because both of those types of questions could show up on your quiz. Okay, we're going to jump into C2, which is graphs of equations. So today is like general graphs of all different types of equations. We then will narrow it down when we get into chapter 1. We'll talk about first lines, and then we get into like parent functions, quadratics, and square roots, and cubics, and all that stuff. So we're just going to talk about some general stuff about graphs of equations. First of all, that if a point is on the graph, if it said that a point is on the graph, then when you take that point and you plug it into the equation, the result will be a balanced equation. Like the left side will equal the right side. So if I wanted to check a point, or if I wanted to plug in a point, that's what I could do to check to make sure that it's on the graph itself without actually having to graph it. So you might see something that looks like this. Determine whether the given point is on the graph of the equation. Did I give you both or did I? You can erase the second one. I feel like once you understand the first question, you're done. You don't need to do it again. So x squared plus xy plus y squared equals 4. And I'm trying to see if 0, negative 2 is in there. So 0 is my x. Everything does not like my pen today. 0 is my x. Negative 2 is my y. And I'm going to plug them in. So everywhere there's an x, I plug in a 0. Everywhere there's a y, I plugged in a negative 2. And then I'm going to simplify it. So 0 squared is 0. 0 times negative 2 is also 0. And negative 2 squared is 4. And I get 4 equals 4. True statement? Yes. So the answer is yes. That point would be on the graph of that equation. If you plug in the second point, you end up with an unbalanced equation. It's not a true statement, so that one would be no. Okay. Again, like yesterday's example 1, not a quiz question, but this is kind of your reminder that if you ever needed to check a point, whether you're graphing it or you're trying to find the equation, if you plug in a point from the graph, it should work into that equation. All right, now we're going to graph. So this is like a general plan to graph. It's going to be more specific depending on the types of graph. But in general, if it's possible, you're going to rewrite the equation so that one of the variables is isolated on one side of the equation. Usually, not all the time, but usually it's a y equals. If we're going to use our graphing utility, it has to be a y equals. It could also be an x equals. Like if you remember parabolas or conics, like parabolas that are turned on the sides, those are y equals equations. I mean, x equals equations. But more often than not, they're y equals. Then if you had no idea what the graph looked like, you could make a table of values like a t-chart. You could plug them in. You could plot your points. You could connect here. This is if you have no previous knowledge of how to graph it, okay? This gives you the t-chart. So hopefully we know that A would be what shape? what would y equals negative 3x plus 1 produce? A line, right? We know how to graph a line. Yes? Yeah. For right now, if I give you the t-chart, plug in those points and fill in the rest of it. So even though I could use my y-intercept and my slope to graph this, I'm going to use the t-chart. So negative 3 times negative 1 plus 1 is 3 plus 1, which is 4. Negative 3 times 0 plus 1, 0 plus 1, which is 1. Negative 3 times 1 plus 1, negative 3 plus 1, negative 2. Negative 3 times 2 plus 1, negative 6 plus 1, negative 5. And then that bottom row is just the coordinate point formed by those. And then we're going to plot those points. Negative 1, 4, 0, 1, 1, negative 2, and 2, negative 5. And just like we thought, it forms the line. Go to B. Same thing here. So what do we think B is going to look like? What happens when your x is squared? It's a parabola. So we expect it to look like a parabola. If I was just plotting points and I was in the quadratic section, which we will spend plenty of times in quadratics, don't you worry, but it's like chapter 2. Then I would plot points specifically that would go around my vertex, that kind of stuff. We're not there yet. We're just saying I'm going to use this t-chart to plug in those points. So I would do negative 1 squared plus 2 times negative 1, and I get 1 minus 2, which is negative 2. And then I get 0 squared plus 2 times 0, which is 0. And then I get 1 squared plus 2 times 1, which is 3. 2 squared plus 2 times 2, 4 plus 4, which is 8. And then again, make your coordinate points. Negative 1, 0, 0, 1, 3, 2, 8. Now we said this should be a parabola and I only have like one side of it. Down the road when we get into quadratics, I would say you need to complete it. I would need to plug in points to the left-hand side. I would need to reflect those. I would need to find the vertex, something more. But where we're at right now, you're simply plotting the points that I give you. So as long as you've got the correct coordinates to this part here, that's all I need for now. Questions? All right, we're going to come back to this example, but I do want you to change it. Make it x to the third. And we're going to come back to using the graphing utility. Because that is not on your quiz. It will be on your test, which is why I'll go back over it. But we'll focus on the things that are on Wednesday's quiz. So intercepts. It doesn't matter what kind of graph we're talking about. It could be a line. It could be like a sine function that like goes all over the place. It doesn't matter what kind of graph it was. You can always find the intercepts the same way. For an x-intercept, we would plug 0 in for y. And then find the corresponding x. And it's where it crosses the x-axis visually. For a y-intercept, we plug 0 in for x. And find the corresponding y. And this is where it crosses the y-axis visually. So it's always the opposite number. There is no rule as to how many there has to have. A graph could have no intercepts whatsoever, right? It could have 2 of each. It could have 1 of one and none of the other. So it all depends on the type of graph. Okay, again, intercept should be in coordinate point form. So my x-intercept is going to be a number, comma, 0, and the y-intercept is going to be 0, comma, that number. If it asks for zeros or solutions or roots, that's the same as the x-intercepts, and those can just be listed. But it asks for your intercepts, you want to put it in coordinate point form. And then we're going to talk about symmetry. So there are three types of symmetry we're going to test for: x-axis, y-axis, and origin. If I'm looking at a graph and it has x-axis symmetry, it means whatever's happening over above the x-axis would reflect down to be below the x-axis. Fold it like a hot dog. I mean like a hamburger, top to bottom. If it's symmetric with respect to the y-axis, then it's right to left. Anything that happens on the right is going to reflect over onto the left. And origin, which tends to be the one that's like the hardest to picture, anything that happens diagonally should repeat. So anything that happens in the top right quadrant should flip down to be in the bottom left quadrant. Anything that happens in the top left quadrant should flip down to be in the bottom right quadrant. So something like a cubic function is symmetric to the origin. If I take this and I flip it over top to bottom and then left to right and I fold it into one quadrant, it would overlap. Something like the y equals negative x line would also be symmetric to the origin. If I take this and flip it top to bottom and then left to right, they would overlap. Yeah.
So basically the x squared functions are symmetric on that.
If they don't have a horizontal shift. Yes. Yep. And absolute value without a horizontal shift. And yeah. So that's visually. Now let's talk about what if I don't know what the graph looks like? What if I only have the equation, right? The way I test it algebraically is for the x-axis symmetry, I plug a negative y in place of the y. So wherever there's a y, I plug in a negative y. If I'm testing for the y-axis symmetry, I replace x with negative x. And if I'm testing for the origin, I replace both x with negative x and y with negative y. And then in each case, after you replace them, you see if your equation simplifies. So if it's something like in the parentheses, I have a negative x, but then I'm squaring that, my negative is going to go away. If I have x by itself and in an absolute value, and I put in a negative x, it's going to go back to positive x. So anything that can simplify, we simplify. And then we compare what we get with our original. If it goes back to the original or it's the same as the original, then it passes whatever that test was, and it would be symmetric to whichever one it is. Or each term is the exact opposite. Then it also would have symmetry to whichever it was. So things like squareds are obviously going to make a negative go away. Things like absolute value are going to make a negative go away. Any even power is going to make a negative go away. Doesn't mean everything that has a square, everything that has an even power is symmetric, because if it's in parentheses with something else, it won't. But if that variable is by itself and it is raised to an even power, it's going to have symmetry to whatever that test is. And then if every term has something raised to an odd power, now it's going to have symmetry to the origin, because every single term will have changed signs. So we're going to kind of all build the intercepts and the symmetry together. Let's go to example 4. It says graph the following equation using intercept, symmetry, and additional points. So we're going to start with our intercepts. I'll start with my x-intercepts. Actually, let's start with the y-intercepts. Those are the easy one. How do I find the y-intercept? Good. Plug 0 in for x. So I'd get y equals absolute value of 2 minus 0. Y equals absolute value of 2. And what's the absolute value of 2? Positive 2. With me so far? Good? Okay. Now I'm going to find my x-intercepts. How do I do that? Plug 0 in for y. So I get 0 equals absolute value of 2 minus x. How do I solve an absolute value equation? What do I do to get rid of those absolute value bars?
That's positive.
So it doesn't change anything inside if there's a variable. If the number's by itself and I'm simplifying, it changes the sign. If it's an absolute value of negative 3, it becomes positive 3. But when I'm solving for what's inside the absolute value, I don't actually change anything inside the absolute value. I will look at what it's equal to. So if this said the absolute 1 equals the absolute value of 2 minus x, that means that the absolute value, whatever's in there, could be a positive 1. It could also be a negative 1, right? Because then it would make it positive 1. So in a situation like that, I would say 2 minus x equals 1, but 2 minus x can also equal negative 1. And I'd get 2 answers. So if absolute value equals a positive number, I also set it equal to the negative, and I solve both ways. Does this seem familiar now? Yes? Okay. But we have 0. Is there such a thing as plus or minus 0? No. So I simply ignore the absolute value bars, and I say 0 equals 2 minus x, so x equals 2. And that coordinate point is 2, 0. I'm going to bring in a coordinate plane. You could be super cool like me and have a coordinate plane saved in your favorites on your iPad. That's how you know you're super cool. Feel free to do the same because we're going to do it a lot this year. And I'm going to plot those 2 points. So I've got 0, 2, and 2, 0. I need at least 3 points to figure out my shape. So this is not enough yet. If from my intercepts I get 3 points and I know the overall shape, I could plot it. But right now I don't have enough information. It also asks me to figure out my symmetry. So we're going to do that next. How do I test for x-axis symmetry?
I had a question.
Oh, yeah.
For the x, why isn't it -2?
For here?
Yes.
So you could move the 2, but then you have -2 equals negative x.
Oh.
Or you could add the x. I try to keep the x positive, so I just move the x.
Okay.
All right, how do I test for x-axis symmetry?
You turn the y negative.
Make the y negative. So it's going to be negative y equals absolute value of 2 minus x. Then I say, can I simplify this? Is there anything there? Is there a squared? Is it in the absolute value, something by itself that I can simplify? And the answer is no. So that stays the way it is. Now I compare it back to the original. Does this equation, the one we just made, match my original? No. Is each sign, so if there's 3 terms, the sign on each of those 3 terms has to be opposite. Is it the opposite of my original? The y changed, but did the 2 change? No. Did the x change? No. So then it does not have x-axis symmetry. If it did have x-axis symmetry, then I could come back over here and I could say if this point is a point on my graph, then so is this. And now I have my graph. It's an absolute value, so it should be a V, and I could have had my shape that way. But it did not. So that does not help you. It helps you to know it doesn't exist, okay? Now I'm going to do y-axis. How do I do y-axis symmetry?
You turn the x into
Make the x negative, so I get 2 minus a negative x. What is minus a negative x change to? Plus x. So now I get the absolute value of 2 plus x equals y. Does that equal the original? No. Did every term change sign?
No.
Nope, just one. So it also does not have symmetry to the y-axis. If it did have symmetry to the y-axis, then I can take this coordinate point at 2, 0, and I could reflect it over here, and then I would have had my V. But that's not the case. Okay, so we're going to say negative y equals absolute value of 2 minus a negative x. For origin, we change both. That inside the absolute value becomes 2 plus x. Now, it's not the same. Did all 3 signs change?
No.
No, we were close this time. We got 2 sign changes, but not all 3, which means it also is not symmetric to the origin. If it was symmetric to the origin and I had a point in this quadrant, I could reflect it to this quadrant. So if I knew 1, 1 existed, I could make it -1, -1. So that's how I could use origin symmetry. But none of that helped me this time, which means I fall to the last part of this instructions, which is I need additional points, okay? So if your symmetry and your intercepts give you enough to know what your graph looks like, you do not need to do the additional points. But if you don't have enough information yet, this is when we do a little bit of extra work. I would also say this is when your knowledge of your parent functions from Algebra 2 help you, because it's absolute value, right? Do you remember what an absolute value graph looks like? It's a V shape, yes? Do we know what happens when we have something inside the absolute value bars? What kind of shift is that? It's right or left. If there's a negative on the x, so normally, because that's a positive 2, I would actually go to the left 2, but because the negative is on the x, it flips it. So that's what's happened here. It took my v, and it shifted to the right 2. Now, if you don't remember any of that, that's okay. We're going to get back to it. That's like section 1.3. We're going to get back to it. But that does mean that you're going to be the person that has to plug in some extra points. So I could plug in a point from over here, but it's not going to help me because it's just going to keep going up this way. If I plug in a point from over here, now I'm going to get the other side to come back up. So plug in 3, plug in 4, plug in 5. It doesn't matter. I'll plug in 3 just because it's the smallest, but it doesn't matter what you plug in. I get y equals absolute value of 2 minus 3. Y equals absolute value of negative 1. So y equals 1. So when we plugged in 3, we got 1. And now I know this graph has this overall shape. You are going to have a question on your quiz that puts all that together. It's going to ask you about symmetry, it's going to ask you about your intercepts, and it's going to ask you to graph it. It doesn't have to be perfect, but it needs to be at least those types of questions need to be answered. And then if you still don't know what your graph looks like or you're unsure, that just means you're plugging in extra points. Questions so far? Okay, we're going to do one more, and then I'll go back to the graphing calculator, and then we'll come back. Same set of instructions. Graph the following equation using intercepts, symmetry, additional points. So I'm going to go a little bit faster this time, but we're going to do the same steps. X-intercept. Actually, we're going to do the y-intercept because they said that's easier. Y-intercept is when x is 0. So y equals 4 minus 0 squared. Y equals 4. X-intercept when y is 0. I can add the x squared so it stays positive. I get x squared equals 4. How do I get rid of a squared? Square root. When I square root both sides of the equation, you have to remember to plus or minus it. So I get x equals plus and minus the square root of 4, which is 2. Which means you have 2 x-intercepts, one at negative 2, 0, and one at positive 2, 0. I'm going to pull in my graph again. And I'm going to plot what I know already. 0, 4, negative 2, positive 2. Based on your parent functions, what's the overall shape? Do you remember? X squared is parabola. That 4 by itself, not inside the parentheses, is your vertical shift, right? Shifted up 4. And the negative on the x squared points it down. So if you know all that, if you remember all that, then we're on the right track here, and we literally could graph based on those 3 points. You wouldn't have to plug in any additional points.
Do you still have to do the symmetry?
The question will still ask about symmetry. Okay. Yep, so we're still going to test for symmetry. So x-axis, we're plugging in a negative y. There's nothing to simplify. It doesn't go back to the original. And they're not all opposite, so it does not have symmetry to the x-axis. If you look at my graph, that's consistent with what we drew. Then we get y-axis. I plug in a negative x. And when we plug it in, it goes into parentheses in with the variable. So if that is squared, what happens to that negative? It goes back to positive. So the minus outside the parentheses are still there, but the negative inside goes away. And this time what happened? It matches the original, right? Which means it does have y-axis symmetry. And if you look at my graph, if I fold it along the y-axis, it overlaps, which is consistent with what we just found. And then the last one is your origin. Negative y equals 4 minus a negative x squared. The negative y stays. The x squared becomes positive. It does not match your original, and they are not all different. So it does not have origin symmetry either. Questions so far? We turned it on. Okay. Now, in order to graph anything, hang on. We're going to hit the y equals. So y equals in the top left. We're going to hit the y equals. This starts with a fraction that 1 over 30 can be typed in a couple different ways. So depending on the type of calculator you have, you might have a shortcut. You might not. Don't panic if you don't, because you can just go back old school. But if you have this button, let it help you out. Even if you don't see it, you might still have it. Everybody hit alpha, and then hit the button next to it. That's the variable button. And see if it pulls up a fraction. How many of yours does? You lucky little devils. Mine does not, okay? So that's your shortcut to a fraction, and you're gonna use it sporadically, so you might as well just learn where it is, okay? If you don't have that, then your second shortcut is hitting alpha y equals. If you hit alpha y equals, you get this little menu pops up, and n/d is the first one. Hit enter on that, and now you get your little fraction bar. If none of that works, then you're opening the parentheses, you're doing 1 divided by 30, you're closing your parentheses, okay? But obviously these are easier to type, especially the more complicated the fractions become. All right, so I'm gonna do 1 over 30. I'm gonna go next to it. I'm gonna do x, because that's what it said to do. Open the parentheses. I didn't write it down. What is the next thing I told you to do? X to the third, right? This is your variable button. So x, the caret is your exponent. Caret 3. Arrow to the right to get out of the exponent. What's the next thing on your thing? What's your slide say? Minus 10 x what? Squared? Plus 39. And then you don't have to close it at the end, but you do have to hit enter. And then we hit graph. Okay, so this is what your graph looks like. Yes? Everybody got it to match? I changed it. That's a really ugly graph, so change it. It's complicated. We're going to ease up a little bit. All right, now, an x-intercept occurs where it crosses to the x-axis. How many x-intercepts are on this graph?
3.
There's 3, right? It goes down, comes back up again, goes down again, right? So there's a couple different ways to find those points. One, you're lucky, and if you hit trace, a little I call it a spider. A little spider appears. And sometimes it falls directly on that point. You get a 0, and you'll know your answer. Like here, that happens, 0, 0. But the other zeros, notice it doesn't happen, okay? So I would not rely on your spider. The second way to do it, and the best way to do it, is in the menu that's above the trace. So I do second trace, and I get the calculate menu. And this is gonna become your new best friend, because we're gonna do 0, min, max, intersect, all within this chapter. Right now, we wanna find a 0, because a 0 is the same thing as an x-intercept. I wanna go left of that x-intercept, and I'm there now, so I hit enter. Then it says right bound, so I arrow right until I pass the 0. I'll know because my y changed signs. I hit enter. And then it says guess, and I'm ready for it to guess, so I hit enter, and it brings me to the first zero, which is negative 1.816704. I think your quiz says to round to the near, or no, your test when you get to it, round to the nearest 10th. So that would be like negative 1.8. And then I'm going to do it again for the next one. So we already know the zero, so I'm going to skip that. Oh, wait, I hit the wrong button, sorry. We know the one at the middle is 0, 0, so that means my next x-intercept is 0, 0. To find the last one, I want to go left of it, I'm left of it. Then I want to go right of it, I'm right of it. Then I want to guess, I hit enter, and it brings you to your next 0. So the 3 x-intercepts were that first one, the negative, whatever it was, 2 point whatever, or 1 point whatever, 0, and then this one, that's 2.2.